In this lesson, we're going to talk about a different way to describe angles, and the terminology we use is common out there with surveyors and other people that are measuring angles from different objects. So the terminology we're going to use is angle of elevation when looking up at an object and angle of depression when looking down at an object. So here is a diagram kind of showing the two different angles. The angle of elevation, if I start at eye level and look up, like the dog is looking up at the bird, this is the angle of elevation. Angle of depression if I start at eye level, which is horizontal, and look down. So the angle of depression is up there. So if you look at this diagram, we have seen this before. I have a horizontal line and a horizontal line, and then I have a transversal. So what do you think is true about the relationship between the angle of depression and the angle of elevation? And hopefully you are seeing that these horizontal lines are parallel, and we know that if parallel lines are cut by a transversal, then alternate interior angles are congruent. So they would be congruent. They are equal in measure. So when you are drawing the diagram, you need to know that, because a lot of times we have trouble with the angle of depression, because when you draw your standard diagram, it kind of looks like this. Angle of elevation is down here, and that is also where you would put the angle of depression, because the angle of depression is this angle, not the one at the top inside the triangle. So angle of depression can be analyzed by putting it down here, the same as angle of elevation. Because of parallel lines cut by a transversal, alternate interior angles, they are the same measurement. So we're going to work through the examples on this page, and then the last page we're going to save for working together in class. So we'll do 3 examples for our notes. Example 1, a man standing on level ground is 1,000 feet away from the base of a 350-foot tall building. So let's draw that diagram. I'm going to have my triangle, and the ground is going to be at right angles to the building. So the building is 350 feet tall, and the man is standing 1,000 feet away. Find the nearest degree, the measure of the angle of elevation, that's this angle down here, from the horizontal, it's always from the horizontal, to the top of the building. Okay, well, look at your diagram. Now this is what we did the other day. Relative to this angle, this is adjacent, this is opposite, so that means I'm going to use the tangent function. The tangent of x is equal to 350 over 1,000, which means x is going to be the inverse tangent of 350 over 1,000. Let's see, what are we trying to round to? To the nearest degree. There it is in italics. You got to make sure you round to the right thing. Once I put that in my calculator, x is approximately 19 degrees. So the actual work of the problem isn't different than what we've been doing. We just have to understand how to set up the correct diagram when I have angle of elevation or angle of depression. Okay, the second example. A person measures the angle of depression from the top of a wall to a point on the ground. So if I have a wall, there's my wall, here's the ground, so there's my right angle. The angle of depression is always measured from the horizontal. So it's going to be this angle, which means it's also going to be the bottom right. The point is located on level ground 62 feet from the base of the wall. So 62 is down here, and the angle of depression is 52 degrees. How far is the person from the point on the ground? So the person's up here. We want to find this distance. So there's my x. So now looking at my triangle, I have adjacent, I want hypotenuse, so the trig function to use is cosine. The cosine of 52 is 62 over x. Converting to a 4-digit decimal, 0.6157 over 1 is 62 over x. So then I have to divide by that decimal. And to the nearest tenth, x is going to be approximately 100.7 feet. Make sure you round to the correct place. So in this example, again, angle of depression is not in here. It's out here. It's always from the horizontal, which puts it in the same spot as angle of elevation. Okay, finally we have one where an offset is involved. I have Scott, whose eye level is 1.5 meters above the ground. So that is actually this horizontal distance, 1.5, from there to there. He stands 30 meters from a tree, so drawing is clearly not to scale. That's 30. And the angle of elevation of a bird, so he sees a bird up there, is 36 degrees. I want to know how tall the tree is to the nearest tenth. Okay, or how far above the ground the bird is, which is the height of the tree. So here's my triangle. This is the piece I can find with trig, but just remember I have to add that offset at the end because I want to know the height from the ground to the bird. My angle of elevation is 36 degrees. I'm 30 meters away. So with that diagram, I have adjacent, I need opposite. That means it's tangent. The tangent of 36 is equal to x over 30. 0.7265 over 1 is equal to x over 30. And x is going to be approximately 21.8. That's not my final answer, though, because I got to add the offset. So the final answer is 23.3 meters. Those are some examples of using angle of elevation and angle of depression, and we're going to work the last two in class and then do some more practice work with it.